Today I am going to start third chapter, trigonometry. It is quite necessary to understand the fundamentals about this new branch of mathematics. As you know, trigonometry is the branch of mathematics. It is a science of measuring angles and sides of a triangle. Literally, that we can say it is a science of measuring sides and angles of a triangle. Even we see that trigonometry, it is a study of 6 elements, 3 angles and 3 sides of a triangle. But here we see that measuring the angles and the problems related to these angles. Trigonometry deals with the measurement of angles of a triangle and the problems related to these angles. That is called trigonometry. In depth, when you think of trigonometry, the 2 Greek words trigono and metry. Trigonometry. Trigono means triangle, metry means measurement. In one line explanation, triangle measurement. In triangle, what we say? Only 3 angles and 3 sides, about which we are studying. That is nothing but new branch of mathematics, that is called trigonometry. I hope now one line explanation that you can understand. Study of triangles is called trigonometry. But after this, we are very particular about the angles, because sides of a triangle 3 that you can measure very easily in terms of millimeters, in terms of centimeters. However, the requirement we go for measuring the sides of a triangle. Whereas when you measure the angles, here basically the 2 systems we are using. That one is very important to understand, the system of measurements of a triangle, basically angle. So what I tell now, what is angle and how we measure the angles, how many systems are there to measure the angle. So first I say that what is angle. Look here, if I take one ray, for example, OA is the ray. Why I say the word ray? Because it has the direction. If it is shown by arrow mark direction, that time we say that OA is the ray. That generally we write ray is in this fashion with arrow mark. That is the vector quantity representing this. The ray is rotating about its one end O, takes the final position like this, B. So the angle is formed here. That is called theta. So what is the angle? This is the amount of rotation. Once again, the amount of rotation from initial position to terminal position. This is called initial position, or you can see initial side of this angle, and this side is terminal side of the angle. Terminal side of the angle. So what do you say now? Angle is nothing but the amount of rotation about its one end from initial side to terminal side. The amount at which, see, this angle is formed about one end, this is called, we tell, vertex, we tell. What we tell? Vertex. Try to understand. OA is the initial side, OB is the terminal side, O is the vertex. This angle AOB, we tell. This angle is AOB, that is taken as symbol. So this is a symbol for angle AOB. Angle AOB is how much you have taken? Theta is considered. So once again I repeat that the study of triangle in which sides and angles, and also the study of the problems related to these angles, and the angle is the amount of rotation of the ray about its one end, and the angle is being formed. So OA is the initial side of angle, and OB is the terminal side of the angle. Angle AOB is written like this, and that is theta. So this is all about the angle here we have taken, and O is the vertex. So the amount of rotation from the initial side to the terminal side is nothing but measure of an angle. You can see the amount of rotation from initial side to terminal side, it is the measure of an angle. And basically when you see that, when that initial ray OA rotates about its one end, here is the point O, and takes the final position, that is OB, we say that angle AOB has been formed. And here OA and OB respectively terminal, initial and terminal sides of the triangle, and the amount of rotation from initial side to terminal side is called measure of the angle, you can say. And here we have to tell that angle may be positive and negative. Positive, negative angle, we say that suppose this OA rotating about this, suppose if it is rotating in this direction, this is OB, and this is called a positive angle, you tell. So what? The ray is rotating in the anti-clockwise direction, the angle is positive. Suppose this OA ray here, suppose this is anti-clockwise direction, suppose if it is rotating in the clockwise direction and this direction, this is negative angle, you tell. What you have to tell? Negative angle. When the negative angle is formed, the direction of the rotation is clockwise, negative, anti-clockwise, positive. So this is the way how we say that angle is positive and angle is negative. And try to understand that basically we have to tell when the positive angle is formed, when the negative angle is formed. So the direction of the rotation is anti-clockwise, positive angle is formed, and if it is clockwise, negative angle is formed. So mainly the two systems we use to measure the angle. How many systems? Two systems. So first one is that we have to tell sexagesimal system. Sexagesimal system. And second one is circular system. How many systems we use to measure an angle? Two systems. One is sexagesimal, second one is circular system. Sexagesimal system is nothing but degree measure. Sexagesimal system means what? It is a British system. What system that is? British system. That is called degree measure. Whereas that circular system, that is nothing but radian measure. Either you say sexagesimal system, circular system. The same things can be explained degree measure, circular measure. That is one and the same. So now here you have to see that first I want to tell that sexagesimal, that is called degree measure. What do you say? Degree measure. And the second one is called circular measure. Circular measure. And try to understand this degree measure and circular. This is a what do you say? Sexagesimal system, that is called circular system, or you can see this circular system may be taken as a radian measure. What you say? This a radian measure. What you say? This is a radian measure. One is degree measure and other one is circular measure or radian measure. Now I have to understand here there are two systems: sexagesimal system, circular system. Sexagesimal system is nothing but degree measure. Circular system is nothing but radian measure. How many systems totally we have? Two. How many measure to measure an angle? Two. So first I have to explain all about the degree measure, and finally I come to see that radian measure. So what is degree measure? So in this degree measure, how we define this? So here that angle is formed. That angle is formed by rotating the ray. Basically that angle traced out by a moving line about a point, and from its initial position to the terminal position in making what 360th of 100 1 divided by 360th of, and the complete revolution, we can say complete revolution of a circle. So that is said to have measure of, that is a degree, 1 degree, and 1 degree is denoted by, say first I want to explain all about the degree. 1 degree is denoted by like this. This is like this. So once again I explain that what is this degree system. The angle traced out, particularly the angle traced out by a moving line about a point, particularly from initial position to the terminal position, in making 1 divided by 360th of 1 revolution of a circle. 1 revolution or 1 complete revolution of the circle, and that is said to have measure of 1 degree. So try to understand. In shortcut I want to tell what is degree measure. So degree measure is nothing but 1 divided by 360th part of 1 revolution in a circle. That's all. That is called 1 degree. How do you find 1 degree? 1 divided by 360th part of 1 revolution. In 1 revolution the angle is formed, that angle is divided by 360, you will get it 1 degree. Degree, it is a measure of an angle that can be obtained, that is the angle traced out by a moving line from initial position to the final position, and how much you have to take? 1 by 360th part of 1 revolution of a circle. In short, 1 divided by 360 into 1 revolution of a circle, that is called 1 degree, and that is denoted by this one small circle. 1 degree is written in that fashion. So 160, that is 160th part. Now here, particularly in degree measure, that subunits also there. What subunits? If this degree is divided by into 60 equal parts, that is called minute, that is denoted by dash. See how you are finding the minutes? That degrees divided by 60 means 60 a degree can be divided into 60 equal parts. Each part is called a degree. Each part of a called is a minute. What I mean to say, 1 degree is divided into 60 parts. Each part is called a minute. And ultimately, 1 degree is equal to 60 minutes. And try to understand that each minute again further divided into 60 equal parts, that each is called second. Ultimately, 1 minute equal to 60 seconds. See, 1 dash if you write, it is minute. Double dash you write, it is second. Small circle you write, it is a degree. This is what you say in all the way. However, you can understand the degree measure. So, angle measuring, that usually in a degree measure, how we define degree, that already I have told you. Even I have told you what are the subunits. But in general, according to the previous standard, 1 right angle means 90 degree. Make it a basic concept that 1 right angle is what? 90 degree. Straight angle means what? 180 degree. Degree you understand. 1 right angle means how many degree? 90 degree. 1 straight angle is how many degree? 180 degree. So the measures of the angles that we can go for according to the diagrams. Suppose if I say, you can say this is 40 degree. Yes. This is 40 degree, O, A, B, and even if you say this is O, A and B, and try to understand, this is 180 degree. Even if you see this is O, A, the rotation of the ray is like this, and you see this is 270 degree. Even if you go for taking O, A, rotating complete one rotation from here, and here you can see that 360 degree. Here 40 degree, 180 degree, 270 degree, 360 degree. So however you can see, suppose if that angle is, this is O, A, if you go for like this is B, and ultimately this you may go for a minus 40 degree. So it is clockwise, it is negative. Anti-clockwise, it is positive. These are the ways how you go for finding the angles in degrees. So once again, degree means 1 by 360th part of 1 complete revolution of a circle. In complete, suppose if you say, if it is that this angle is part of 1 complete revolution, and this angle divided by 360, and that one we call it as what? It is nothing but degree. So now we say that degree is nothing but 1 by 360th part of 1 revolution of a circle. And these are the diagrams, and which you can see that how we represent geometrically negative or positive angles. Likewise, now I want to say that another system, that is called a circular system, and thereby you can see that measurement of angle is nothing but radian measure. So now here I want to explain that what is radian measure. The second system, circular system, in which I am going to discuss about a radian measure. So here I want to tell this is a circle. Try to understand. This circle is center is O, radius is R. Look this, that angle is, I want to take this OAB. This is 1 radian, I tell. 1 radian. So here you have to tell what is the definition of radian. Define a radian. Define radian means you have to tell radian is the angle subtended at the center of a circle by an arc. AB is arc. By an arc whose length is equal to the radius of the circle, and this is called 1 radian. Once again I repeat, very important definition. Define radian. 2 marks may ask. What is radian? Radian is the angle subtended at the center of a circle by an arc whose length is equal to the radius of the circle. So, radian is the angle subtended at the center by an arc whose length is equal to the radius. So, that is why this R I have taken. Understand? This is the radian. And you go for understanding that the radian measurement, how we go for taking this definition in other way. So suppose if you say that a circle if I take, and you can tell that it is a center. So if I take like this, how many radians? How many radians? So here I told you radian means this arc is equal to this radius. And here you have to tell what is the angle subtended here. It is suppose if you take unit circle, if I take what I say, take unit circle. If it is a unit circle means the radius is equal to 1. And ultimately you have to see that this R by R is 1, and here the circumference, that is 2 pi divided by 1, and theta is 2 pi radian. Means that the center at the circle is 2 pi radian. How you understanding that? It is nothing but the ratio of circumference of a circle to its radius of the circle. Radian, other definition you can say ratio of, that is arc length to its radius. Arc length. Suppose if I take arc length to its radius, that is nothing but R by R, it is nothing but 1 radian. Radian symbol, sometimes we write this small arc. 1 bar, small arc, that is a symbol. How do you say degree is a small circle, radian is arc, that is nothing but small c. So we have to go for understanding that radian is nothing but the ratio of arc length and radius of that circle. So once again you understand that the angle subtended, because basically we have to see that that angle subtended is 2 pi. And what is this angle subtended center of circle? As you know in the previous standard, 360 degree. So 2 pi radian is equal to 360 degree. Pi radian is equal to 360 by 2. Pi radian is equal to 180 degree. Now we have to understand this definition. Pi radian is equal to 180 degree. How you have got this formula pi equal to 180 degree? Because when the angle subtended at the center of the circle by an arc, whole circumference circle, that is 2 pi, and about the unit circle I am talking, so that pi radian is equal to 180 degree. So here you have to see that ultimately 1 radian definition is 180 divided by pi degree. 1 radian is equal to 180 by pi, and here this pi is, the value of pi is 22 by 7 or 3.142 dash dash. But when you talk about the angle, it should be 180 degree. Don't get confusion. And sometimes we write, we are not writing C. This is understood if I write only pi. pi, you have to read it Greek letter pi radians equal to 180 degree, and you need not write this. See, may be written, may not be written, but the value of pi, when you are talking about the angles 180 degree, when you are taking the value of this pi, it is 22 by 7. Pi is 22 by 7 or 3.142 dash dash. If that pi is representing the angle and you have to tell pi equal to 180 degree, that is understood. Pi radians is equal to 180 degree. So here you understood what is a radian and what is the angle subtended at the center of a circle. And basically when you are going to see the result here, and I want to tell you certain important conversion, and accordingly you have to tell. Suppose you radian and degree, in the examination they give for radian and converting to degree. They give degree converting radian. So you say the formula. Now I have to tell phi radian equal to 180 degree, and here you can tell that r 180 degree equal to pi radian. So these are the two possibilities that we are going to write it. And when you write that, basically pi radian, the formula can be written, this 1 radian is equal to 1 radian equal to 1 divided by 180 divided by pi, this is degree. This is 1 degree is equal to what? Pi by 180, this is radian. Look, this 1 radian is equal to 180 divided by 5 degree. This pi is 22 by 7. 1 degree is equal to pi by 180. So here you see 1 degree is equal to pi by 180. These are the two important conversions, degree to radian, radian to degree. So now I want to go for, in general, degree to what? Radians, and that you can remember and use it. Basically I tell you that 30 degree, you see this 30 degree, 45 degree, 60 degree, 90 degree, and so these are very important result. So this is taken as this is in degree measure, and radian measure, this is pi by 6. How you say pi by 6? You try to understand. Pi by 6 radian is equal, pi means 180 by 6. So 6 ones are 6, so 30 degree. So 30 degree is equal to pi by 6. And 45 degree means pi by 4. And this is pi by 3. And this is pi by 2. So you can go for degree to radian or radian to degree. These are the standard angles that you see, degree and radians. So the two formula I have told you, one formula is 1 degree, 1 radian is how much? 1 degree is how much? So 1 radian means, here you are told that 1 radian is 180 by 5 degree, and 1 degree means what? Here 1 degree 360 degree equal to pi, and pi by, and you have to see this particularly when the result you are writing 180 degree is equal to pi radian. So 1 degree is equal to pi by 180 radians. These are the two conversions that you can use it. Now coming to the point here, finally the two, at least I have to discuss 3 important results I want to discuss, and those are results that can be proved, but that proving is not important in the examination. Even that proving is not given in the textbook. Even then I have to consider 3 important results. So why I am considering the 3 important results? Those results are important in CE, CET or any competitive exams. So that is why I have to discuss 3 important results of associated with angles and measurement. First one is that radian is constant angle. Radian is a constant angle. The first result you see. How do you say radian is not changing circle to circle? Because why I am talking about this? Here I tell that it is 1 radian. Suppose if I take the big circle and again it is 1. So don't think that radian is not changing according to the circle, big or small. However, maybe the circle, that radian is constant. How do you say it is a constant? That I want to explain. How do you take the conclusion that radian is a constant angle? So here you see that basically that already I told you 2 pi radian is equal to, we have already discussed, 360 degree. Yes or no? This we have discussed. 2 pi radians is equal to 360 degree, and ultimately you have to tell that pi radians is equal to 180 degree, and one radian is equal to 180 by pi what degree. So pi is also constant, 180 is also constant, and 1 radian is also constant. From this we take the conclusion that radian is a constant angle. Why? Because 180 is constant and pi is constant, ultimately constant by constant, so that 1 radian is constant. This is the way how we tell that radian is a constant angle. This is one result. And second result I want to tell that basically, see, with the usual notations you can prove that L is equal to r theta. With the usual notations means what? Suppose if you take a circle, usual notation means r is the radius, and here try to understand this OA, and here I tell B, this is arc length, this is L, and angle is theta, our radius is r. Usual notation means L r theta. So we have to prove that L is equal to r theta. So here you can go for understanding that theta is nothing but it is a ratio of that arc length to its radius. Theta is this angle, radian is the angle, it is a ratio of what? That arc which subtends the angle at the center to its ratio. So theta equal to L by R, or L is equal to r theta. So how do you understand this? When that angle is the ratio of the arc which subtends the angle at the center in radian to its radius of the circle. So ultimately you can understand that how we take the conclusion L is equal to r theta. It is a second result. Now I am going to explain that area of the sector, what do you say, with the usual notations here also, with the usual notation, what area of the sector is equal to 1 upon 2 r square theta. With the usual notation means r is the radius of the circle, theta is the angle subtended. So look this is a circle, and try to understand this is r, O, A, this B, and this is the sector. This is the sector. This area of the sector is given by formula 1 upon 2 r square theta. Theta is angle subtended at the center by this arc 1 upon 2 r square theta. So how we prove that? Area of the sector, this AOB is equal to 1 upon 2 r square theta. So that I want to prove here. And this formula may be used in the next future studies. That is why I have to discuss how you will get this formula 1 upon 2 r square theta. Basically that we know that in a circle of radius r, and you see that look this radius r. Suppose this total angle if you take here, and what is the angle here? 2 pi radians we have taken. See that basically area of the circle formula is pi r square. You know this area of the circle is pi r square. But we want to discuss only area of this sector, not full circle, only this part. This part only we have to discuss. So here you understand that as we know, basically that the angle 2 pi radian trace the area, how much? Pi r square. So 2 pi radian trace the area, how much? Pi r square. 2 pi radian means whole circle. And what is the area of the circle of radius r? Pi r square. So here you understand 2 pi radian what trace the or gives the area is nothing but pi r square. Once again I explain that we know that the radius r of a circle, particularly that angle 2 pi radian trace out the area is how much? Pi r square. Therefore, area of this sector AOB, that how much it gives, and accordingly in theta is the angle at the center, and that is given by. So here you see that area A is equal to total area of the circle is how much? Pi r square. So here you understand that whole 2 pi, it becomes area is pi r square. But now we have to go for taking that angle subtended, that is theta. So area of the sector we have to understand, and accordingly we can go for it. So here you see that when theta is, if you take it area, how much radians here? 2 pi, and here is the angle is theta. So now you can understand that when you see that this area full circle is there, and area is what you say? Pi r square. And suppose if I go for only the part, that angle, this arc length, that is 1 by 2/5, that area. So suppose if it is full area, and you have to tell that pi r square, and here you see this the same. Now you cancel it, pi, what will be the answer here? 2 by r square theta. So here we understand that area of the sector is 1/2 r square theta, because it all depends on area of the circle, because the angle that 2 pi radian traces the area pi r square. So you have to understand that the angle theta traces how much? That is theta by 2 pi. Theta by angle divided by 2, the ratio of theta by 2 pi. So 1/2 r square theta. So how many results that I have told you? 3 results. One is radian is a constant angle, and second one is L equal to r theta, where L is the length of an arc and theta is the angle subtended at the center by that arc. And the last one is area of the sector is 1/2 r square theta. So now here I want to discuss some problems, degree to radian, radian to degree. First I want to discuss certain problems. Number 1, you have to see that how the problems that can be solved. So question is, convert the following into radian measure. Number 1, 25 degree, 2, 240 degree, 3, 520 degree, 4, 225 degree, 5, 150 degree, 6, 330 degree, 7, minus 47 degree, 30 minutes, and 8, you have to see that 40 degree, 20 minutes. So here the problems that you can see how we convert in the radian. These are in degree. We have to convert into radian measure. So see the result, how we can find out solution. Once again I explain that how we convert degree to radian measure. Convert the following into radian measure. There are 8 problems which are there in radian degrees that should be converted into radian. So the simple method I am using, and accordingly you can see the result. So we have to convert degree to and you see that we know simple method. We know that degree 180 degrees is equal to how many radian? 5 degree. 1 degree is equal to pi by 180 radian. So therefore you tell 25 degree is equal to 25 into pi by 180 radian. So this is you have to simplify and I write the answer. And here you have to see 5 3s are 15 and 5 6s and 5 5s. So 5 pi by 36 watt radian. The first answer is, you can write that 5 pi by 16 radian. So now I have to go for converting all problems into a radian. So converting degree to radian, only one that I have done. So once again I say that 1 degree equal to pi by 180 radian. So second problem is what? 240 second. Once again you write what? If you are getting confusion, 180 degree is equal to pi radian. 1 degree is equal to pi by 180 radian. So second problem is how much this? Second one is 240 degree. Therefore 240 degree is equal to 240 into pi by 180. So here you see that 6 3s are 6 4s are. So 2 pi by 3. And here you have to see that you have to go for using that 6 3s are 18, 6 4s are. Means that you have to go for using that 4 pi by 3. 4 pi by 3 is what? Radian. And here you understood that how you have got 4 pi by 3. So like that you have to do it. Today I want to use all degree to radian. In the next class we have to take radian to degree. What is the number 3 here? 3 is 520 degree. See, 520 degree. First I have to tell once again what? 180 degree is equal to pi radian. 1 degree is equal to pi by 180 radian. The question is how much? That is 520 degree is equal to 520 into pi by 180. So you have to simplify this and accordingly. So 2 2s are 2 1s are 2 how much? And here you have to see that 2 9s. Again you have to see 3 3s are 3 7. So 7 pi by 3. You have to see that answer is how much? You have to see 520 degree is equal to, and so you have to simplify. Once again you have to see this how it should be simplified. You have to cancel it, and 520, look this, 520 into pi by 180 radian. So this is cancelling. Now you have to go for taking so 2 2s are 4 and 2 6s are 12. Here 9, and here you have to see 26 pi by 9. Is there? It is not possible. 3 3s are no. So 26 pi by 9 radian. What you say? And this is the final answer. Now like that you have to go for fourth one. How we convert that fourth one? That is number 4. Here once again I write what is the number 4 here. 225 degree. See, 180 degree is equal to pi radian. 1 degree is equal to pi by 180 radian. And the question is 225 degrees equal to 225 into pi by 180. So here you have to understand that how many radians you will get it. So cancel it accordingly. We can see 5 3s are 15, pi 6 there, and 5 fours are 20 and 5 fives are. Next you have to see that 3 ones are 3 fives are 15. Here 3 ones are 3 twos are. And even you can see 3 fours are 12, 3 fives are 15. So 5 by 4 radians. How many you got it? 5 by 4 radians. Yes, it is all depending on how you are simplifying. Now you can go for number 5. Number 5 is what you see here. 150 degree. 150 degree, number 5. See that 1 degree is equal to 5 radian. 1 degree equal to 5 by 180 radian. Question number 5 is how much? 150 degree is equal to 150 divided by 180 radian. And you have to simplify now here. 5 threes are, or you can see this how you can say simplifying. And accordingly you can say 3 6 are 18, 3 5 are 5 by 6 radian. And try to understand how you got 5 by 6. And next one is 330 degree. Next one is what? Sixth one is 330 degree. And sixth one, 330 degree is equal to 330 into 5 by 180. And here you have to see that 3 1 are 3 6 are. So 11 5 by 6 radian. And this is the way. Now last part 1 is 7. You take it minus 47 degree and 30 minutes. It should be converted into what radian measure. Now I am explaining this 47 degree. How much? 30 minutes. And how you have to convert. So look this minus, I want to write very clearly that minus 47 degree 30 minutes is equal to, minus keep it out, 40 degree. So here you have to understand how many minutes is equal to 1 degree? 60 minutes. See here, try to understand 1 degree, see 60 minutes is equal to 1 degree. 1 minute equal to 1 by 60 degree. So here 30 degree means 30 by 60 degree. Try to understand this. And minus keep 47, how many degree? That is plus 1 upon 2. This is degree. You have to simplify this. LCM is what? 2. And here 94 plus 1. So what is this? Minus 95 by 2 what? Degree. Minus 95 by 2 degree here. So here you have to see that 95 by 2 you can go for, and it should be converted into what? Radian. That I am explaining. So degree 2 you have to multiply by 180. So this is equal to minus 95 by 2 into, and already I have told you pi, what do you say, 1 degree is equal to pi radian, and 1 degree is equal to pi by 180. So here this degree means pi by 180. This is nothing but radian. So you have to simplify this, and accordingly you can write the answer. So now I say that if you go for pi by 180, to simplify this, what happens now here? Is there any possibility? So 5 ones are 5 and 5 nines are. And here you see that 5 threes are 15, 5 6 are 30. Here 5 ones are 5 nines are. So what comes? Minus 19.5 divided by 72. What do you understand here? Minus 19.5 divided by 72. What this is? A radian. So now you go for similarly that 10th one, and that is the last problem, how we can write it. See this. What is the next one is? Next one is 40 degree 20 minutes. See, eighth one 40 degree 20 minutes. See, 40 degree plus, look this, 1 degree is equal to 16 minutes, or 60 minutes equal to 1 degree, 1 minute equal to 1 by 60 degree. So 1 minute equal to 1 by 60, 20 minutes equal to 20 by 60 degree. So what happens? 40 degree plus, that is 1 by 3 degree. So this is 40 plus 1 by 3 degree. So you have to take the LCM, and 120 plus 1. So that 121 by 3, what is this? Degree. 121 and by 3, and accordingly you have to see. Now we have to convert into what? Radian. What should be multiplied here? You have to multiply it by 5 by 180. So what comes now? You see, this is equal to 121 by 3 into, you have to see that degree, and here you have to see 180, 5 by 180, this is radian. And when you write pi by 180 radian, and you have to simplify this, and is there any possibility to simplify here now? 121 pi, and 18 threes are 54, 540 radian. So this is the way how to convert degree to radians, and in the next class, and I have to discuss that how to convert that radian to degree. Thank you.